What if the most destructive things in the entire universe are actually the key to understanding how it all began? Today we're going to get into the mind of Stephen Hawking. This was a man who stared right into the abyss of black holes and totally rewrote the laws of physics, all while fighting his own personal battle against time.
This right here? This is the exact question Stephen Hawking spent his life trying to answer. He looked at black holes, these things so dense, with gravity so intense, that once you're in, not even light can get out. So, let's dive in. We're going to crack open his cosmic rulebook, starting with an idea that sounds really simple, but, well, it would go on to change absolutely everything.
Okay, so picture this. You're at Cambridge. Hawking is this brilliant, kind of rebellious young researcher. And along with other great minds like Roger Penrose, he decides to tackle the two biggest puzzles out there: the fiery birth of the universe, the Big Bang, and these bizarre black holes that seem to just swallow physics itself.
His first huge breakthrough came back in 1971. It was called the area theorem. And, like I said, it sounds simple, but trust me, the implications sent shockwaves through the world of physics.
All right, before we go any further, we need to get our heads around this one concept: the event horizon. The easiest way to think of it is as the black hole's surface. It's the ultimate point of no return. Cross that line, and you're not coming back.
So Hawking's theorem made this just mind-bending prediction. Using pure math, he proved that if two black holes smashed into each other and merge, the surface area of the new, bigger event horizon can never, ever get smaller. It's a one-way street. The area has to get bigger, always.
So what? Why was that such a huge deal? Well, because this simple rule was the first real clue that black holes were connected to a fundamental law of physics we see everywhere else, the second law of thermodynamics. That's the one that says disorder, or entropy, in a system always goes up. Hawking basically showed that black holes, in their own wild way, play by a similar rule.
But hang on, because Hawking was just getting warmed up. A few years later, he made another discovery, and this one would completely upend everything we thought we knew about black holes.
You know that old idea of black holes as these perfect, eternal cosmic prisons, the ultimate one-way street? Well, in 1974, Hawking came along and basically said, actually, that's wrong. He completely shattered that picture.
By mashing together quantum mechanics and gravity, which nobody thought you could do, he proved that black holes aren't perfectly black. They actually have a temperature. They glow just a tiny bit, leaking energy and losing mass. And over unimaginable amounts of time, they can actually evaporate.
This is a great way to think about it. You know how a radioactive atom spits out particles as it decays? Hawking realized a black hole does something similar, just slowly leaking energy out into space. It was a revolutionary idea, to say the least.
Okay, so these were some wild ideas from 50 years ago. The big question is, how did they hold up? Did modern science prove him right?
For decades, Hawking's theorem was just a beautiful piece of math on a page. But then, in 2015, everything changed. The LIGO Observatory detected gravitational waves for the very first time, actual ripples in space-time from two black holes colliding. And suddenly, scientists had the data they needed to test his idea.
And the result? Well, by listening to the before and after echoes of that cosmic smash-up, physicists confirmed Hawking's area theorem. And not by a little. They confirmed it with 95% confidence. His rule, written half a century earlier, was right on the money.
Of course, Hawking's impact went way beyond academic papers. He became one of the greatest science communicators of all time. Through his books, he made the biggest, most complex mysteries of the universe something that millions of us could get excited about.
But for all his cosmic work, his most profound legacy might not be out there in the stars. It might be right here, in how his journey connects back to the limitless potential of the human mind.
As motor neuron disease took more and more from him physically, his mind was still free to explore the universe. He worked side by side with engineers to build incredible communication systems, constantly pushing the limits of assistive technology.
And the technology he helped create, like Intel's open-source ACAT toolkit, wasn't just for him. It was designed to give a voice to countless other people living with debilitating conditions. It's just a powerful testament to his drive to empower others.
In the end, Stephen Hawking showed us that a single mind, when it's amplified by technology and driven by just sheer determination, can literally reach across the cosmos and rewrite our understanding of everything. He didn't leave us with all the answers. Instead, he left us with bigger, better questions. Questions that will inspire explorers for generations to come.